Hello and welcome to the Conference Center and GlobalSpec's Quality Test and Measurement online event. Today's ever-increasing manufacturing process challenges are being supported by a new breed of low-cost, automated optical inspection solutions. A single platform can now support inbound part and first article inspection, process setup, process control, and full product traceability. Embracing this new technology gives manufacturers a competitive edge. Before introducing our speaker, we'd like to invite you to submit questions at any point during this presentation by using the Enter Question and Submit area at the base of this video console. Also, some of the presentations you will see today include detailed information, so we encourage you to click the Download PPT button so that you can follow along with your own copy of the PowerPoint slides. Bill Loving is founder, president, and CEO of ScanCAD International. Bill focuses his energy on ScanCAD's product leadership in support of today's dynamic global manufacturing challenges. Bill, hello and welcome to our event.
Thank you, Jim. It's my pleasure to be with you today, and I welcome everybody to this presentation. As you're seeing, I am focused today on today's flexible multi-purpose inspection systems, specifically process setup, process control, and product traceability all on one platform. For the agenda today, I've got a brief introduction, and then we'll dive into a tool that's used for this process setup, a process control tool. We will spend time on the electronics industry because that happens to be in my background. As a matter of fact, you can see here, for example, is a motherboard from a PC. We will dive into the technology itself, the inspection process, and then take a look at some data creation capability that's part of this system. And I want to stress that this works in many different industries, not just electronics, so it transfers very, very well. And again, of course, a couple of conclusions. I'd like to start by just sort of focusing with each of you on your own pressures, your unique pressures, and how you move through your individual manufacturing environments. Because what we notice around the world today is that many people are being asked to manufacture products that were designed by other people, designed completely different departments, even possibly different parts of the world. And you in the manufacturing environment are required to use equipment from a variety of sources, raw materials from different sources, and processes, a wide variety of processes that include possibly chemicals, etching, plating, different kinds of adhesives, etc., just lots of different kinds of processes. Mix in that a variety of skill level of people. In many cases, the feature sizes of the products you're working with are getting smaller and smaller. You've got always this time to market pressure. You've got to do this, maintaining compliance at all times, traceability. You've got cost constraints. Many of you run 24/7. And then, especially for the folks of you listening that are part of the medical, safety-related automotive, aerospace applications, etc., you've got to do that with 100% traceability. And of course, you've got to do all of this with zero defect. So when I say a challenging environment, I think you all know what I'm talking about. So that's what I'd like to start out with, because that's what this is all focused on. Now the bottom line is, most of you have been using the same tools now for a long, long time. These include granite-based coordinate measure machines, optical comparators, calipers, micrometers, scopes, that kind of thing. Essentially, there hasn't been really major changes in this environment for at least 30, 40 years. So what we're looking at today is diving into a whole new philosophy. Now, to start with, let's just lock into this whole thing. The philosophy isn't new, but the tool is new. When I say process control, I really mean no surprises. Now, I'd like to define what I mean by process setup. The whole idea here is to catch problems before the production floor. We'd like to simulate production using actual parts. We'd like to overlay all the variables in a virtual environment and perform any kind of tweaking that you need before production. The whole idea is the data coming from these CAD systems actually matches the parts that are on the floor, and you don't have surprises. And then yes, when you move into a production environment, we'd like to have real-time control. We'd like to close the loop. We'd like to watch the process. We want direct feedback. So up front, we'd like to sort of share that in my presentation, that we really want to focus on those areas. Now, what is needed is a low-cost, flexible system that can do all of that. And there are technologies available that are out there that do this. Obviously, by doing it, we do eliminate rework. We in those surprises on the floor. And using this kind of a tool, you can do SPC sampling versus traditional high-cost single-function type systems that tend to be in your process, which would be more on that closed-loop side. What do one of these multi-purpose inspection systems look like? Well, here's a photograph right here that'll show you. Essentially, it's a bench-type system. Basically, it's very flexible. You can use it in a variety of different areas, supporting multiple lines in different parts of your facility. And the whole idea is to keep its general purpose, just like calipers, just like a micrometer or a coordinate measuring machine. However, in this case, this system permits 100% inspection. And we'll talk more about that in a second. Also, in the same system, you are able to make CAD data. You can actually generate measurement data right from the system, possibly used further on in your processes. The whole idea here is keep it PC-based, easy to use, low cost, etc. So that's what these systems are looking like. Now, as I shared, I want to spend a little bit on inspection versus measurement. Inspection, when I say inspection, I'm talking about 100% of the part. The output here is either a pass or a fail. In this case, we are talking about scanner-based systems for these low-cost systems. In the case of a measurement system, as I shared earlier, that tend to be very expensive, granite-based, they take a high skill level to operate the thing, and you're looking at very specific items within a product. Certainly not 100% inspection. If you were, it would take forever and ever to do it. Just way, way too slow. So really, inspection systems are designed to complement measurement systems. They really do work together. They work together. I've got an example here that I'll show you. There's also a short little video that can be played while I share this as well, showing this how this works. But essentially, I'm showing you now a wafer bump stencil. There are over 750,000 apertures on this stencil that you see right here, and each aperture, each opening is 50 micron or 2 mil in diameter. Now, I think you understand that a measurement system would be impossible to detect errors in this type of thing. There's no way you could measure 750,000 apertures, but an inspection system does just that. It performs 100% inspection. So on the screen you see and on the video, you'll see these errors of partially blocked apertures, missing apertures, etc. This can be after a cleaning process. I will use electronics here. This is a wafer bump stencil, but the same technology is being used today in the textile industry, looking at dye, where you're extruding liquid polymers through very small openings. These die have to be open, and this is the way to perform 100% inspection. So that's inspection versus measurement. Let's dive into the electronics industry for a second. The technology I'm talking about has been used in the data creation area for the last 23, 24 years in the electronics industry. And it's only been applied to inspection here in the last 12 years. When I'm talking electronics industry, I really specifically am looking at the solder paste stencils, which are actually printing paste onto boards such as this. I'm looking at emulsion screens that are used in the hybrid manufacturing or on ceramics, and also photo tools, film, glass, chrome, that kind of thing. Now, and I also have some video here that can be played so you can take a look at this as well. I've got a stencil that I'll be showing you. In this stencil, you can see the inspection taking place. There are a variety of errors that you see on the stencil that you're seeing right now, including blocked apertures, incorrect apertures, possibly a wrong revision of a stencil. All of this you're finding out pre-production before you get onto a production line. In the case of emulsion screen, I've got a short video showing you here, and I want to point out on this one, the traces, the openings on this screen are only 1.5 mil, 35 micron, and we're performing 100% inspection before that screen goes into a production operation. Very, very important. The same kind of process can happen on a film. I've got just a brief bit of film showing scratches, pinholes, mouse bites, that type of thing on the film. So again, I'm hoping you're seeing those and you can appreciate the power of this technology for the electronics industry. Now let's take a look at just some images here that I have showing bare printed circuit boards, flex circuits, silver epoxy on circuit boards, a red glue that you see here, loaded populated boards components, printed materials on LTCC, low temperature co-fired ceramics, thick film printing, that type of thing. These are all application areas today where this multi-purpose technology is being used. I have here some examples of solder paste, again silver epoxy in a microwave, military type application. Here we've got some laser drilled holes in substrates. These could be laser drilled holes in ceramic materials. This is being used today in the photovoltaic environment. Actually, laser holes in that whatever that polysilicon crystal stuff is. But anyway, in the solar industry, we also have wire bonds. I've got some supporting video here that you're going to take a look at that looks at solder paste inspection, so you can actually see incorrect paste deposits. And this is being done on the same system that was inspecting the stencil and the emulsion screen and the photo tool a couple minutes ago. That's because these multi-purpose systems today have focus capability. We can actually hold the part up off the surface of the scanner, and we can look at wet materials like solder paste. And so you're seeing that on the screen. Also, you're looking at now you'll be looking at a hybrid part. And you see we're looking down in the cavity of this hybrid part. And inside the cavity, you see wire bonds, you see components, you see adhesive, you see printed resistors, all kinds of interesting materials down in here. I like to share these images with you because it really just brings to focus the complexity that each of you have in your manufacturing environments and how this inspection tool can be applied. Now that we've talked about up front about the philosophy and that introduction and a little bit of electronics industry, let's look at the technology that's behind this system. Now, I mentioned earlier that there's a scanner involved, a flatbed scanner, and really this is the key to these multi-purpose inspection systems that are being deployed around the world. This flatbed scanner, it operates in black and white or in color and at very high resolutions. All the way up to over 12,000 dots per inch. Most manufacturing environments operate at about 1,000 dpi or 2,000 dpi, but it will operate at much higher resolutions if necessary. Like, for example, those wire bonds we saw a second ago were all scanned probably around 3,000 dpi, which would be about, oh gosh, around an 8 micron pixel size, something like that, because the wire bonds themselves are less than 1 mil in diameter. Now, these systems can be calibrated or not. In case of the image you see here, we're looking at a NIST certified calibrated system, and I've got some footage of an actual system in use that you can take a look at of that scanner actually operating. Okay. There's a scanner evolution. Another reason why we've embraced this technology and why you see it being used for inspection in the last 12 years, it was about 12 years ago these things were released in color. So it was really only until right around the end of the 1990s that we moved into a color environment with these flatbed devices. So on the screen here, I just want to point out that one of these flatbed scanners is equivalent to 220 10 megapixel cameras firing at maximum resolution onto something like this circuit board. That's 2.2 gigapixels. So just to put it in perspective, these flatbed scanners really are a very smart package. I've got some images here. Again, wire bonds you're taking a look at are the 0.7 mil wires. And I want to also just drop a comment now on the PCM or photochemical machining industry for any of you who happen to be involved in that. That's chemically etching small metal parts, whether electronics or otherwise. Again, it can be applied in this environment. Why? Because the lighting can be from the top or the bottom. So we can image dry parts, wet parts, etc., etc. Again, calibrated. And these inspection systems can go to golden board data or CAD data. So you can actually teach an existing part and have all other parts match that part. There are a couple other configurations for these low-cost systems. I've been talking mainly about the bench system at this point, but on the screen you will see that there is a conveyorized version as well as a downward-looking system. What's interesting is the same scanner is in all three of these systems. In the conveyor and the desktop unit, the scanner is looking down. In the bench system or in the desk system, the scanner is looking up. So yes, you can use these in inline environments as well as offline environments. But the focus primarily is in this offline environment. Now I want to spend for just a couple minutes just sort of sharing that not only can it be used for inspection, but you can also use this for data creation. Again, it is a multi-purpose tool. Now let's go through the inspection process. I've got sort of a 7-step I want to share with you here real quickly, just giving you an idea of the flow and also conveying the simplicity of the system. It's designed to be used by low skill level people out on the floor. Yes, it'll be set up by a manufacturing engineer. Yes, you'll have data coming into it that'll be coming from your CAD department or from some of your manufacturing and engineering areas. But the fact is, it is set up to be used on the floor. So here we have an example of importing the CAD data. CAD data here is displayed in green in color. If we're scanning, for example, a stencil or a screen, and let me just show this image here. This is an emulsion screen or a solder paste stencil. Basically, you don't need to operate in color in these environments because you are really putting light through the openings, and you're making sure the openings are clear and ready for production. So the image you see on the screen is of the openings, which happen to be blue in this case. So here you've got the green CAD data, the blue opening. The system is designed to line these two images, perform an inspection, and show any place where there's an error. Bring that to the operator's attention so they can clean those out, make sure that everything's okay, confirm that you have the right release of stencil that's going to be used or the right release of a screen, etc., etc. Again, what are you doing here? You're making sure that all the variables come together in a virtual environment before you get actually on the production floor. Avoiding mistakes, avoiding surprises. Yes, you can print a certificate. Obviously at this point there is data being maintained at all time on these systems to be used by SBC and certainly for your ISO certification. Now you remember up front I mentioned in the medical and aerospace areas traceability, traceability, traceability. Well, the fact is with these systems, when you perform an inspection on a stencil, on a board, on a component, whatever the product is, you can save the images, save the test data. That's all being logged and you have full traceability, including, if you wish, operator name, date, timestamp, all this type of stuff. Even the date the system was last calibrated. Let me dive in now into the data creation process. There are situations, probably don't want to talk about those, but that's where you have processes that for some reason the CAD data is not available. So I mentioned earlier these systems can be used to go for inspection purposes against golden board data, or in some cases you actually need to make CAD data that matches the actual part. So what I want to share with you here is the same system that performs inspection can be used to create data. Now the image on the screen, you can see we can create data from a bare circuit board, from a stencil. We could import CAD data, for example, and verify it matches the right release. If you do have a mismatch on release, you can then see where the mismatch is, make a correction, and move forward. I've got an example here of a multi-layer PCB, and we're actually going to run some footage for you that shows, looking at the top of a multi-layer PCB, we will flip to the bottom so you can see the bottom, and we will then dive in through the layers of this multi-layer PCB. Literally, this system is able to completely reverse engineer or re-engineer an existing circuit board. Again, when data is lost, this is absolutely needed for your test equipment. So this is another capability of these multi-purpose systems. Now, remember what I said a second ago, when you have a circuit board, for example, and you have stencil, and they possibly don't match, maybe slight variations. It could be that this job lot of board, because the fact is, remember I said up front, your raw materials are coming from a variety of sources around the world. You have all these things coming together in your manufacturing environment, and if things don't match up exactly right, you're going to have a production problem. So, with this technology, we can actually image the board, image the stencil, make sure they match perfectly, and if there's any problems any place, we can actually change the stencil data and make a new stencil. In the case of stencils, they're worth about $100 each. Boards, extremely expensive, and you have thousands and thousands of boards, you have a very few number of stencils. So I just want to share with you that's one concept of this technology. And there's an article that's being referenced here from SMT Magazine, April 2006. And this magazine article points out the benefit of moving to, or of altering the data to exactly match the board. So if you look at the graph on the left, you will see that this is data that is simply as it was from the CAD system. And if you were actually to print paste on a board, you can see that we're outside of tolerance on a variety of pads there. Whereas making some small changes, especially on fine pitch devices, we're able to dial that in and actually have a direct match between the stencil and the part. This study, published again April 2006, it was done by Motorola, and they had a 43% reduction in solder paste defects by implementing this type of technology. That's very, very significant. Okay, let's look at some other application areas. Again, I mentioned photochemical machining. In that area, not only can you look at the metal parts being manufactured, but you can look at the photo tools. You can look at the resist, image resist. Make sure that's okay before you even go into the etch process. You can check your first piece. make sure things are okay. You can even check your first piece partially through the etch process, making sure your etch factors are okay, making adjustments as you move forward. And then finally, yes, the finished part. The system, again, being a bench type system, is really designed for SPC, typically not fast enough to do 100% of your production. But again, this first article setup, making sure that first piece is okay, and then you can use SPC or some sampling, if you will, of the finished part using this technology. Okay? And another area is this photo tool inspection. I've got an example here of an optical encoder, and the image you see on the screen actually has a 1 mil blockage or a 25 micron blockage. There is no way that you could see this type of a problem using measurement equipment. And up until this point, many times these are being manually inspected. So this is a great example of where the tool can be used. I've got another image here showing some resist inspection. Again, you're looking here for pinholes, scratches, mouse bites, protrusions, shorts, opens, this kind of a thing. Here's that first piece inspection I mentioned a second ago. So the first part coming out, making sure things are okay. Over etch, under etch in that photochemical machining environment. You're doing 100% inspection. You're checking the entire part. Here we have final part inspection. Here we have a partial etch example. That's where you have full etch all the way through a metal part, and then some symbols, as you can see, have been etched into the surface of this material. Other industries include aerospace, medical, textile industry. I already mentioned the die inspection there. Semiconductor industry, doing ball inspection, doing lead inspection, this type of thing. Automotive industry, many different applications in that environment, especially with the safety related. Solar cell industry and fuel cells. I just have some images here on the screen for you. So really, in conclusion, there's no question that you are each in a challenging manufacturing environment today. And with these new tools, this multi-purpose inspection platform, it opens the door on performing 100% inspection before production, eliminating surprises. And yes, when you are in production, use it for sampling. These systems, just so you know, are typically under $40,000. So they are very affordable and very fast ROI. Again, they're all PC-based, easy to use, and they will assist you in many different areas. So Jim, at this point, I'd like to pass it back to you.
Okay, Bill, let's take some questions from the audience. Please give a real-life example of how this type of technology can make a difference.
Jim, I'd be happy to do that. One idea comes right to mind now, or one example. That is in the automotive industry. As I mentioned earlier, these solder paste stencils tend to cost about $100. And in this particular example, they were printing on, I'll just use this example here of a transmission board. And they were printing solder paste for this transmission board. Well, there was one aperture missing. There's probably 2,000 or 3,000 apertures that they're printing paste through onto these apertures. One was missing. There was enough solder on this reflow board that there was an electrical connection after reflow with the test equipment, so it tested electrically just fine. And they ended up shipping, installing, and putting these into over 2,000 automobiles. There was a recall. Fact is, over time, enough vibration that would open, and there was a complete failure. Extremely expensive, and this would have been caught with this type of technology.
Okay, Bill, let's take another question. Why is this technology any better than the expensive high-end automated optical inspection AOI systems that have failed in the past?
Jim, two words come to my mind, offline and 80-20 rule. The inspection or the expensive AOI systems in the past have tried to do it all. So they would be looking at a board like this and trying to do everything on here. Consequently, production was stopping every time one of these boards came through because there was some sort of an area, and the operators would get frustrated and ultimately they would bypass the machine. And so if they're trying to do everything, then it simply didn't get done. So what you have to do with an online expensive AOI system and dummy it down so that you really have open the threshold so these lines will continue to run in mass production. Now, so that's the 80-20 rule. the term offline, the second word is the fact is take it offline. If you want to get really picky, use the inline production systems to do 100% inspection, dummy them down a bit so the boards get through, but then use these new flexible offline systems to pull the board off and get really picky on a statistical sampling basis. So I hope that answers your question, Jim. Or hope that answers the viewer's question.
All right, here's another question. You mentioned a 43% reduction in solder paste defects as measured by a study at Motorola. If the same CAD data is used to make a PCB and the stencil, why don't they match perfectly? And is this common?
Unfortunately, it's more common than we'd all like to believe, but it is very common. You know, the fact is, when people are making these circuit boards these days, they're typically panelized. So when you use CAD data, you make one object, and then they're panelized, making multiple images, if you will, across a panel, obviously for production reasons. So that's one fact. So you take an individual image, and then now you're printing it across multiple images here, so you create a panel of individual boards. Secondly, most manufacturers today have multiple suppliers, typically in multiple countries, for obvious reasons. So now you have these job lots of boards coming in large volume to your manufacturing facility. So you've got the CAD data that went overseas, the boards come back, or from different areas, they come on back. You have the original CAD data, which is one up, you have this panel, and now they use this one up data to go off and make a stencil. The stencil comes in and put this together. Now shockingly enough, 98% of the time, the stencil and the circuit board come together for the first time on the production floor, typically on the production line. And what operators do then is they do some tweaking. They try to get this thing so it matches, and they try to make some small adjustments. Well, the fact is, in these new lead-free environments, these new tiny components, fine-pitch devices, etc., it's becoming a really big problem. So that whole concept that Motorola did their study on in 2006 is very real, and there's tremendous benefits of using this technology in this environment. So Jim, it's a good question.
Okay, next question up. Are there some other misalignment type issues for electronics manufacturers in addition to the stencil and PCB problem just described?
Yeah. Obviously, if we have an issue with the stencil and the PCB, which are both based on that CAD data, well, guess what? The entire manufacturing process downline is based on that same CAD data. So all the placement machines, all the test equipment, etc., they're all using fiducials, they're all using the pad information that was from that original CAD information. So again, part of that Motorola study and part of what customers are doing today that are using this technology is they're making those adjustments here, not only for the stencil on the board and manufacturing the stencil to match the board, but they're passing this small change in fiducials and other kinds of information to that other equipment down the line. So there really is a good benefit. Bottom line, you are not tweaking, if you will. That's the word people use. We're not tweaking on the production lines anymore. We're actually pre-tweaking. We're doing all of this in this virtual pre-production process control environment versus actually doing it on the line. Doing it on the line is a very expensive place to do this. If you do it this way, you have dramatic reductions in scrap, rework, etc. So yes, it does filter down the line in many other areas.
Okay, Bill, let's take a look at another question. Who is now using this new technology?
Jim, that's a good question. Well, keeping in mind that this technology really in the inspection area has only been around the last 10, 12 years. So what we found is it's primarily those companies that have been pushing the technology envelope, primarily in Europe, in North America, and in Japan. Those are the initial areas of focus. That's where trace widths and aperture sizes were dropping below that 2 mil or 50 micron level. Component sizes. I mean, remember these electronic components now, 0101 devices, they are so small now that you actually, my joke is you can put it in your eye and they don't even hurt. These things are extremely small. You can hardly see the darn things. So it's really in those environments the technology was initially embraced, but it has been flowing out. And it's now estimated this technology, that the stencil fabricators, the companies that are making these stencils today, that approximately 100% of the users, really it's 99% of the fabricators in North America and Europe and in Japan are now inspecting the stencils using this technology. Now, there are other areas where there's still manual inspection going on for the stencil fabrication. So we estimate today about 50% of the stencils manufactured in the world today are inspected on this low-cost type multi-purpose platform. Now, as far as the stencil users, the numbers are far lower. We're approximately 1% of the stencil users in the world are using this technology. And mainly that's due to awareness. So that's why we have the presentation today, just letting folks know that this technology is out there. Because the focus has been up to this point for the stencil users has been those single function automated inspection systems, or AOI, automated optical inspection systems. Whereas these multi-purpose systems, people don't even know about these things. So this pre-production concept. So we believe that in the next 10 years will be the rapid growth area for this product.
Okay, Bill, next question up. What is the cost for a platform like this?
These platforms are available from a variety of suppliers around the world. There are 4 different suppliers that I'm aware of, and they typically run under $40,000. I think I may have mentioned that during the presentation. There are some of those platforms that are even under $30,000.
Okay, we've got time for a few more questions, and the next one asks, how extensive is the user training needed for this type of tool?
Jim, typically and for the person that asked this question, typically the training is just a couple of hours for the folks that are on the floor. Normally there's some sort of a video, there's a little workflow, if you will, that is used to bring the technician up to speed on it. From the standpoint of the manufacturing engineer to do the programming, because remember a lot of times it can be golden board programming, coming from CAD data, etc. That kind of training typically takes anywhere from 2 to 3 days at the outside. Data creation, probably the most complex process for these platforms. Data creation, by the time you do inspection, data creation, all that, a maximum of 5 days. So from anywhere from a few hours to a maximum of 5 days.
Next question up. Where do you see the next expansion in this product beyond PCB assembly?
Well, as it's pretty obvious, my background is mainly in electronics, so I really speak from that perspective. So from my perspective, I really see this moving more into the component area, things like ball inspection. Let's see if I got a sample here. So of leaded devices, or the small solder balls that are on BGAs, micro BGAs, CBGAs, all these types of things. I really think in the lead and ball inspection are really component inspection. A lot of that inspection today is being done manually.
Okay, Bill, how would you suggest a company get started?
That's a good question. Really, it's you look at where CAD data and actual products come together within your organization. As I said, electronics, not electronics, doesn't make any difference. Where those two come together, you go there and you check to see if there are issues. And I say carefully check, because you've got talented people that are really compensating. They're doing this tweaking I was talking about, getting this stuff to work. So you've got talented people who are absorbing, if you will, those differences. So if you get in there and do some real checking, you can sort of narrow that down in that area. Certainly if you have, in electronics for example, solder paste defects, they all speak to those kinds of things. So look any place there's scrap, rework, as a result of where CAD and actual product come together. That's my suggestion on where to start.
Can a company be too small or too large for this technology?
Good question, Jim. No. I've got an example of an extremely large company that's using this type of technology for film manufacturing in China. They manufacture film on 5-kilometer long rolls that are about 3 meters wide. And this technology inspects the first 2 meters of film on that 5-kilometer roll and the last 2 meters of film. Obviously, that's an example of an extremely large company using this technology. Likewise, I'm aware of companies of just a handful of employees that are using this technology. Why is that? The barrier to entry. Obviously, a system under $40,000, under $30,000 permits it to be used in a wide variety of companies. So, no limitation.
Okay, Bill, we've got time for one more question. Do you see other complementary tools that support this inspection technology?
Yeah, actually I do. there is a new technology out that is focused on interactive, collaborative, paperless work instructions. Essentially, the days of paper travelers and the nightmare associated with revision control and that type of environment are numbered. So we're seeing more and more companies now move to paperless work instructions, and this goes even beyond, for example, making PDFs of Word or PowerPoint or Excel documents. We're talking about actually interactive machines that are using iPads and tablets, if you will, on manufacturing floors. Why do I bring that up, and why do I say that now? Because it's all part of process control and traceability. So it meshes perfectly with this technology. So yeah, I think that is where a complementary tool is that I would focus on right now. Interactive, paperless work instructions.
Okay, Bill Loving of ScanCAD, that's about all the time we have for the questions. Thanks for your time and expertise today. Now, before moving on to explore the exhibit hall of this event, please take a moment to click the Take Survey button and let Bill know how he did today. Your feedback helps us improve the quality of our GlobalSpec events, making them an even better investment of your time. I would like to encourage you to visit the exhibit hall, where you'll find manufacturer product reps, engineers, technical specialists, and other professionals waiting to answer your questions. Remember, exhibitor representatives are only here today, so spend time with them while you can. Join our growing contingent of thought leaders by speaking at one of our events. You can submit your proposal at our event help desk in the exhibit hall. And please visit us at globalspec.com/events to learn more about upcoming online events you won't want to miss. Thank you for sharing your day with us.